You have a couple of options when it comes to creating code that repeats a block of statements while a condition remains true: the while loop and the do while loop. So let's talk about the while loop first. The while loop is the simplest loop that you're going to find. This kind of loop allows you to execute a block of code indefinitely while one or more conditions remain true. Because the condition is evaluated at the beginning of each loop, the loop may never execute if the condition is immediately false. If it's true, the condition is evaluated at the start of each subsequent loop. As long as the condition remains true, the loop keeps executing. You also have options to break out of the loop at any point, either to skip just that instance of the loop and start the next one, or to terminate the loop entirely. So there's a lot of options for how you put together your while loop. In the simplest form of the while loop, the condition never changes. In that case, your code has to execute from the loop on demand. And here I have an example that shows how that works. The idea here is that the example continues to request drive letters from the user until the user presses enter in response to its prompt. Just enter. Okay, so right out of the bat, as soon as the method starts executing, we have while true. This is the conditional statement. True is always true. There isn't anything that is going to change true to false. And so this loop is going to continue to execute indefinitely, at least if it's left to its own devices. Okay, and then it prompts the user for a drive letter, or you can press enter to quit. It reads the line, so the user has to press the enter key. And then it checks to see if the value that the user entered is null or empty. If it is null, then it breaks out of the loop. So it just stops executing the loop and we're done. So this is going to be the case when the user hits enter. That's not a valid drive number. That's going to result in a null or empty drive name, and so it breaks out. Okay, so that's the exit point for the loop. So again, we're not relying on the condition changing, we're relying on explicitly coding how the loop ends. Otherwise, in the else clause here, this is the code that then displays information to the user. So it goes ahead and gets the drive name, it converts it to uppercase, it makes sure that it's between A and Z, so it's comparing A greater than or equal to 0 and Z less than or equal to 0. So it's comparing the drive name to Z. Okay, and then if it does fall within that range, so we're making a little bit more sophisticated kind of an example here. Use the drive info to get information about the drive, and then use the isReady property to see if it's ready. Read the total free space if it is ready. If it's not ready, then it says drive, whatever the drive name is, isn't ready. Okay, and if it's not a valid drive letter, it indicates that. Okay, so I'll go ahead and run this and see how it works. Hit J. Okay, I'll enter a drive C. Has a bunch of free space. I'll enter R. It's not ready. I'll enter K. Not ready. C again. And I can do this all day. And then I hit enter. And that drops out of that while loop. And I hit enter again, or any other key, and I get back to my menu. By the way, that final prompt to press any key to continue, all the sample applications in this part of the C# course use a console menu custom application. It's actually a separate project. If I look at Solution Explorer here and references, you can see that I have a reference to it right there. So that is a wrapper for all of this code, and that wrapper produces that final prompt here. So that's actually happening after this method has finished executing. So don't be confused by that. Okay, so again, simplest example, the while expression, conditional expression here, never changes, so I have to explicitly do something to break out of the loop. But a more common use of while is to actually include a condition that is checked each time the loop executes. So now what's going to happen is that the loop is going to continue looping continuously until the condition that I specify here changes its state. So this example is a variation of the previous example, but this time the code continues looping as long as you continue to enter a valid drive letter. Once you press enter so that the drive name is an empty string, the loop exits. So in essence, we've moved one of the conditions out of the body of the loop and made it part of the loop here. So again, to compare, this condition here is now the condition for the while loop. Okay, so this is really a more realistic way of coding this kind of example. All right, so I start out with the default drive name. All Windows machines have C drives, so, or at least most do. I suppose you could get around it. And then going into the while loop, this is not necessarily true. It is in this case because I'm initializing drive name to something not null and not empty, this while loop is always going to execute at least once. But that's not necessarily the case. Maybe I prompt the user for something up here, maybe I read a value from the registry, I do something else, and there may be a null or empty value. And in that case, if it's null or empty, then this loop never executes in that particular case. All right, in this simple example, it's always going to execute because drive name is always set to a string value. Okay, and then it prompts the user to enter a drive letter, and then it's pretty much the same code from here on. But once it does all this, it then loops back through. It checks again to see if the drive is null or empty. Okay, and so if it is null or empty, then it loops back through this, and then it sees that it's null or empty, and cuts out of the while loop and continues executing right down here, the next statement after the while loop. Okay, so I'm not sure I explained that the best. So let me just run through it one more time and make it a little bit clearer. Okay, so drive name starts out as a non-null, non-empty string. This condition is going to be true, okay? Because if it is null or empty, negating that ends up being true for a value of C. Then it prompts the user for a value. User enters a value, checks to see if it's null or empty. If it is, just skips this if block, goes back to the top of the loop. This condition is evaluated again. Now it's false, and so it drops out of the while loop. But if the user enters a drive letter, then it continues to check it and execute the loop as long as the user continues entering drive letters. Okay, so I'll run this version of it. And that's K. Okay, so I'll enter C. I'll enter D, F. So I'm entering valid values. The value I'm entering is not null or empty. I'll hit enter, and it quits out. It's done with that method, and now it has that press any key to continue that is executed by that console menu object. Okay, and one other thing to point out about this is that one characteristic of this particular while loop is that I'm checking the exit condition within the loop as well as the loop condition. And that's a very common thing you need to do. Not always, because you could write the logic differently, that if something happens, you don't necessarily need to check that. We do here because we need to make sure that we have a drive letter, but you could just let the code drop through execute, and then the exit condition is only executed right there. Okay? So it just depends on how the logic of the loop is put together. Let's talk about the other form of unbounded looping within C#. Now, as I just showed you, the while loop checks its condition at the beginning of the loop. As a result, it's possible that the code within the loop block will never execute. That is, if the condition is false when the loop begins, the code within the loop never runs. And C# provides an alternative. The do while loop checks its condition at the end of the loop, so that you're guaranteed that the code within the loop always executes at least once. So this is quite a different situation as it turns out, but the nice thing about this is that it makes the do while loop better in some kinds of scenarios than the while loop. Here's an example that demonstrates both kinds of loops and really hits home the point about the different ways that they evaluate conditions. So in both cases, the code continues looping as long as I is less than 10. So I have a while loop where I is less than 10, and then I have a do while loop where it's checking to make sure that I is less than 10. Okay, so notice the difference in syntax here, first of all. So I have a do statement, and then I have the block, and then after the closing bracket, I have the while condition, and this is the exact same syntax as the while loop there. But it's just turned upside down, and because we need some sort of a keyword to start the whole thing off, the creators of C# came up with do. Actually, that comes from C and C++. All right, so the way this code is going to go is that I have an integer I that I'm initializing to 10. In this case, because I'm checking to see whether I is less than 10, this condition right out of the gate is false. And so this loop never executes. So this loop doesn't execute. Execution continues immediately after that while loop. It comes in here. The do loop doesn't have any condition, so these lines of code are going to execute no matter what the value of I is or any other condition whatsoever. All right, and so you notice that I have a message it won't execute, but for form I'm including the value. And here it does execute. And then I'm incrementing that value. And now I is going to be 11 when it comes into the condition. That's even more not less than 10. It's more out of the range. And so this loop only executes a single time. Sees that expression is false, drops out to the code immediately after the do while loop. Okay, I'll execute this. And L. And you can see that I got the does execute. So the won't execute statement didn't execute. This one did. So probably the only thing that's not optimal about the do while loop is that this is a very simple example of one, but it shows all the features and how it works. But a lot of the loops that you're likely to write in a real application are likely to have a lot of code. There might be 50 or 75 statements that you need to execute in this loop over and over again as long as the while condition remains true. And so you have the do down here, and so but you don't have the condition until maybe you have to scroll down a couple pages of code before you can see it. So that's kind of a downside to this type of a structure. You can put in regions. I don't have any here, but they allow you to collapse code just like that. These are built in for each method. You could do that, make it a little bit easier to see things. But you can also put a comment here or immediately before the loop that duplicates the condition. And that's a programming standard at a lot of shops. That alleviates the problem, but then it potentially causes other problems because let's say you come in 6 months from now and you have to change this condition and you forget to change the comment that identifies it. Now when you come back in 6 more months later, you look at that and say, oh, that's not what I'm looking for because that's not the condition. You never look down here and you miss the place where a bug is manifesting itself. So there's a lot of pluses and minuses with going both ways. For the most part, though, you want to keep your loops as short and tight as possible. It's just going to be much more efficient. Because unlike a single line of code here, if this is an inefficient line of code, it's only executing once. But if you have a lot of inefficient code within a loop, and the loop is executing 1,000,000 times during program execution, that can really slow down your application.